Well, welcome to Ken's Genius Vision. Well, not exactly a genius. As a matter of fact, I'm a blundering fool. Because I had a perfectly good working operating television, and through some bizarre experimentation, I accidentally short-circuited out the power supply. So now I have to try and fix it if I can. Now I have found, by the way, the television that I'm working on is a Medion 30612 model. Now I've taken out the main board, and it's a very clever kind of TV actually, very clever board, because everything is on the one board. The whole lot. The inverter for the lights, the TV tuner, the AC, DC, everything's on the whole board, so it's very clever. So, the first thing I did notice, it took me a couple of hours to figure out what was going on, but as you can see here, possibly, is that when I was trying to take some voltage measurements around here, I slipped and shorted the probes out. This blew out the fuse. I don't know why I was doing that. It was just absolutely silly. I knew that was working, so but anyway, we won't go into that. It's one of my bizarre tinkerings. I sort of get carried away with trying to figure out how things work and understanding. See, sometimes it's easy to understand how something works when it's actually working than when it's broken. So you know something about the device you're working on, it kind of gives you some general idea of what might be wrong when it's not working. So, one thing I have noticed that I have shorted out the bridge rectifier here, which is 4 diodes. Now if I put the meter into continuity mode, it rings right through every diode. Now that is obviously wrong, and like we've got continuity across the capacitor as well. So what we've got here is a dead short on the bridge rectifier. Now if I'm lucky, which you very rarely are in these cases, then that's I'll only have to replace those 4 diodes and the fuse, and hopefully the TV will fire up again. Now I'd just like to point out a few little tricks that I've learnt myself off the internet actually. And they never taught me this at TAFE, even though I did electronics trade at TAFE. There's a lot of things that, you know, you're always learning with this kind of thing. And once you have the knowledge, that's all well and good, but then one must accumulate experience. And since I no longer work in the field, and I only got a year working in the industry, and it wasn't on televisions. So anyway, to put a long story short, I'll now attempt to desolder these 4 diodes and replace them with the new ones that I bought from element 14. Now, it was a very sad story about returning from element 14 with these parts, because I had to go to a part of town that I wasn't familiar with, and on the way back the GPS led me kind of wildly astray, and I got lost and became very frustrated. So hopefully I'll have better luck with this. So now I've cut one diode out of the circuit just to see what's going to happen here. Now I've still got it on continuity function. Put it back onto diode function. Now positive, oh, that's actually checking out okay, that diode there. We've got 0.5 of voltage drop on the positive bias, and overload on the negative bias. That's where you put the positive on the anode and the negative on the cathode, and you get 0.5. And when you reverse the leads around, you get overload. So this could be proving my theory wrong, but so far, yeah, my diagnosis is kind of like not working out. So because that diode was okay. So we'll cut the other diode out, but there's definitely something funny going on here, I'm sure of it. Now I've still got it on diode check. Yes, this diode here is checking out to be bad. And I'll put it back on the continuity meter. Now I've cut that. That diode's now the lead's been cut out of circuit. Yes, that diode is dead. So now I'm going to cut the lead. This is an easy way to just quickly take the component out of the circuit by just cutting one lead with the wire cutters. Now, believe it or not, this actually won't make it any harder to take the component out when we're desoldering it, because one thing I've learnt over the time I've been tinkering is that when you desolder components, sometimes the component itself acts as a heat sink and absorbs the heat of your soldering iron and makes the component much harder to get out because the solder won't melt properly. So anyway, I'm going to test these other three diodes. I'll just do it on a continuity meter. Yep, all other three diodes are cactus. Absolutely cactus. Now, before I start desoldering, I'm going to put on a bit of PPE as personal protective equipment. I'm going to put some safety glasses on. I'm going to put kind of a heavy glove on over this glove. I'm also going to connect this ESD strap to my wrist because I'm quite sure there's some ESD sensitive components on this board, and if I'm unlucky I may have already damaged it because I was a bit, sometimes I don't think of these things until it's too late. But anyway, we've started to take a few precautions up now. So, until now, I've got very, very basic lab here. Nothing like the lab that I worked in when I was in the industry, but just the basics. Now, if I get more involved with this sort of thing, I may buy some more equipment over time. So the first thing I'm going to do is get some solder. Flip our board around to the back here. Sometimes it's always difficult to figure out who's who and where's where on the board. So I've already lost track of which the good one was. We don't want to take the good one out. So that's actually that one, I think. Yeah, that first one. So that means when I flip it over, the furthest one will be the closest one, and that's the one we'll go from. Sort of from there to there. I'm going to open it from here to there. Oh. So first I'm going to find my solder sucker, which is a piece of equipment that you'll definitely need for this sort of thing. First thing I'm going to do is try to add some heat here and try to get something sucked up. Now, my iron might not have come up to heat yet. Well, I've got something melting here now. Oh, but this is... Now, fortunately for me, I think that this is not lead-free solder, because some of the more modern boards use lead-free solder, or more expensive boards, I'm not sure, but anyway, like it is. And it's pretty well impossible on some boards to take things apart with conventional soldering iron like this. And now I do have this gas-powered soldering iron. Now here's a trick that I learnt actually by watching another tinkerer or tech on eBay, was where you actually put a little bit of solder on the part you're trying to desolder and quickly give it a hit. Believe it or not, that kind of gets it out. See, now it's not quite out, but you That's a little trick that we do sometimes around here, is grab the component by the lead and then like kind of pull down on the board a bit, and then add some heat to the hole and pull. And there you have it, our first dodgy component out. Now, as I was mentioning, I do have this gas-powered so-called soldering iron. Now, it's absolutely useless as a soldering iron. Well, if it isn't, I can't work it as a soldering iron. It's about a blowtorch, it's about as good as it gets. Now, it's got soldering tips, but I've tried to use it and they just don't get hot enough or something. It's just kind of not very good, no. And I wouldn't use it as a blowtorch to melt things on there because, you know, the heat, you could damage components or anything. So it's absolutely kind of useless for electronics work, really. I thought it'd be really good when I bought it, but it looks really good and it's got soldering tips and it runs off gas, and maybe I'll figure out how to use it or something, make use of it somehow one day, but at the moment it's not really part of the program. So anyway, I'm probably going to be running out of video time in a minute, and if you're interested in to see how the rest of this repair goes, then I'll be making another video to follow up very shortly, and you can follow the story from there. Bye for now.